So, as you can see here, we have the Basis 3 board, and this is the xADC input header here. I've basically, to get a 1 volt differential, I have created this circuitry over here, and did a little math. I found that between the positive and negative rail over here, there was 3.32 1 volts, and so I did a little math to find out what I had to do to just get 1 volt out of that. So I built a voltage divider here out of 2 variable 10K resistors, and did the math pretty easy on my calculator here. Let's see, it was just, if this thing will focus, right there. So I first put in 3.321 right there towards the bottom, and then I took 1 volt, which is what I wanted, and divided it by that to get 30 point. Whoop, calculator likes to only stay on very long, not very long if you're using it. So it, I took and I got 30% basically out of the 1 resistor. To make a 1 volt differential, I'll need 1 resistor to be about 70% and the other one to be about 30% in order to get that differential. So I just took these 2 resistors right here, and I dialed one of them into about 700k ohm, or sorry, 7k ohm. That would be this back one here, and then the front one here, I have adjusted to be starting point right at about 3k ohm. So if you watch, you'll see this is the actual project. This is what happens. So 255 is my max number there. I'll explain in the code, but this was aliasing before, not clearly shifting, and I put in some code to slow that down, so now you can distinguish between a 4 and a 5 and not some weird combination. Anyways, this is how it works. So when you adjust right here, so right now we would be, if it's reading 255, this means that our differential pair is, I believe, closest to each other, meaning they're almost the same value. Oh, no, it's the opposite. So they're the furthest away from each other, so the difference between the 2 wires is 1 volt. So to change that, you turn this potentiometer with a little screwdriver, as you can see here. And so we'll start turning it here. And you'll watch this number, because it's an 8-bit ADC. You can watch the number drop from 255, which is 2 to the 8th, down to, and there's also a bar graph here created with the LEDs to kind of show you where you're at. And it'll go all the way down to 0 or 1. And that's how she works. That was the plan right there. Initially, this was going to be used with a water flow meter, which would have created with some additional circuitry to the meter, depending on what style of meter it was and what kind of signal it gave off. This was originally going to be hooked up to that system, and the flow of water would have created a 1 volt differential that would have went into here, and then we could have used that input somehow in the CAD, if you will, code or CAD that we program into the FPGA in order to output something something useful like flow rate or usage per day, something like that. So right now you could basically think of it as 0 water flowing and now we have maximum water flowing up here. All right.